Okay, stay positive. Collect your paper and pen. The serious stage of our lecture. Application of criterions. Now, farmer want to decide which of 3 crops he should plant on his 100-acre farm. Now, the profit depends on the rainfall during the season. يعتمد على المطر يعني خلال الموسم. The farmer has classified the rainfall as high, medium and low. أمطار شديدة، أمطار متوسطة، أمطار ضعيفة. He estimated profit of each as follows. طيب. When the rain is high, the expected profit of crop A is $8,000. Of group B is 3,500, and is of group C is $5,100. When the rainfall is medium, then he estimated his profit of group A 4,500 for A, again 4,500 for B, and 5,100 for C. The last expectations are when the rainfall is low is 2,000 for group A, 5,000 for B, and 4,000 for C. But farmer wishes to grow or to plant only one crop. Decide which is the best using Maximax, Maximize, Hoyt's, Laplace, and regret criterion. Collect your energy and let us collectively apply the previous instructions and steps to advise this smart farmer. Okay? This is table 1, payoff matrix. Rainfall, high, medium, low. Maxi payoff and min payoff. Estimated conditional profit. Check the column and the group A. Various levels of profit: 8,000, 4,500, 2,000. The maximum among these 3 indicators is 8,000. The minimum is 2,000. let us shift to the right for group B, where the maximum payoff is 5,000 and the minimum payoff is 3,500. For group C, the maximum also here is 5,000 and the minimum is 4,000. A. Maximax payoff is 8,000. Then the best strategy is to choose group A. Compare with the group B 5,000 only and group C 5,000 only. Let us move to the next max mine. The various levels of mines are 2,000, 3,500 and 4,000. The maximum among these mine payoff is 4,000. Hence, the best alternative is C. Do you see how it is attractive and excited? Very possible. Very possible. Very easy. Just draw the table of payoff. Add row of max payoff and add row of mine payoff according to the given data. The best profit for group A is 8,000. The maximum. The minimum is 2,000. For B, the maximum is 5,000. The minimum is 3,500. For C, the maximum is 5,000. The minimum is 4,000. Then, the maximum of the maximum is 8,000. Thus, A is attractive. Group A is attractive. The max mine among 2,000, 3,500 and 4,000 is 4,000. Then the best alternative is group C. Its criterion. Given the coefficient alpha equals 0.6, this for optimism. For pessimism is 1 negative alpha 0.4, and refer to table 1. The maximum payoff for group A is 8,000, for B is 5,000, for C also is 5,000. Mine payoff for A is 2,000, for B 3,500, for C is 4,000. Okay, now we are going to calculate what? H equal alpha, the coefficient alpha, multiply by what? By maximum, of course. Multiply by I plus 1 negative alpha multiplied by double I. I, it is Max, logical, and double I, it is mine. So H equal alpha times I, or between brackets Max payoff, plus 1 negative alpha times double I. Double I stands for mine payoff. So $8,000 or 0.6 multiplied by 8,000 plus 0.4 multiplied by 2,000. The result is what? 5,600. This ash for group A. For group B, respectively, 0.6 times 5,000 plus 0.4 times 3,500. The result is 4,400. For group C, the max payoff is 5,000. The mine payoff is 4,000. Then ash equal 0.6 multiplied by 5,000 plus 0.4 multiplied by 4,000. The result is 4,600. The maximum value of ash is 5,600, corresponding to group A. Hence, the best choice is A. Okay, that's good. This according to what? Howitz criterion. Howitz criterion. Let's move to Laplace criterion. There are three states of nature. There are three states of nature. Then Laplace criterion, referring to the first table or to the given table. There are three states of nature for each group. For A, it is 8,000, 4,500 and 2,000. Three states of nature. Okay, three states: high rainfall, medium rainfall and low rainfall. Please don't focus on the given table. Return back to the first table. Now, estimation, group A equal 1 over 3 state of nature, then 1 over 3 multiplied by 8,000 plus 4,500 plus 2,000. The harvest is 4,833. For group B is again 1 over 3 because they are also 3 states of nature. 1 over 3 should be multiplied by 2000 plus 3500 plus 4000. The result is 4333. For group A is, for group C, again 1 over 3 multiply by 5000 plus 5000 plus 4000 equal 4666. This is Laplace criterion. The Laplace criterion. Okay. Now, the maximum expected value according to the above calculation is 4833 for group A. Hence, group A is said to be the best choice. Is said to be the best choice. Okay. I would like you to storm your brain and to conduct the solution of the regret criterion. The regret criterion. It will be very rational issue to understand the theory of decision. I would like to thank you very much for your patience. This is the last lecture of operations research. I will do my best to react to your questions, problems, as I promised before. Do your best. Try to jump over the difficulties, struggle, and as we say, قدام, go قدام, and I'm trusting your perch and well. Take your decisions. Never give up. What's criterion? What's criterion? Given the coefficient alpha equals 0.6, this for optimism. For pessimism is 1 negative alpha 0.4, and refer to table 1. The maximum payoff for group A is 8,000, for B is 5,000, for C also is 5,000. My payoff for A is 2,000, for B 3,500, for C is 4,000. Okay. Now we are going to calculate what? H. H equal alpha, the coefficient alpha, multiply by what? By maximum, of course. Multiply by I plus 1 negative alpha multiply by double I. I, it is max, logical, and double I, it is mine. So H equal alpha times I, or between brackets max payoff, plus 1 negative alpha times double I. Double I stands for mine pay off. So $8,000 or 0.6 multiplied by 8,000 plus 0.4 multiplied by 2,000. The result is what? 5,600. This ash for group A. For group B, respectively, 0.6 times 5,000 plus 0.4 times 3,500. The result is 4,400. For group C, the max payoff is 5,000. The mine payoff is 4,000. Then ash equal 0.6 multiplied by 5,000 plus 0.4 multiplied by 4,000. The result is 4,600. The maximum value of ash is 5,600, corresponding to group A. Hence, the best choice is A. Okay, that's good. This according to what? Howitz criterion. Howitz criterion. Let's move to Laplace criterion. There are three states of nature. There are three states of nature. Then Laplace criterion, referring to the first table or to the given table. There are three states of nature for each group. For A, it is 8,000, 4,500 and 2,000. Three states of nature. Okay, three states: high rainfall, medium rainfall and low rainfall. Please don't focus on the given table. Return back to the first table. Now, estimation, group A equal 1 over 3 state of nature, then 1 over 3 multiplied by 8,000 plus 4,500 plus 2,000. The harvest is 4,833. For group B is again 1 over 3 because they are also three states of nature. 1 over 3 should be multiplied by 2000 plus 3500 plus 4000. The result is 4333. For group C, again 1/3 multiply by 5000 plus 5000 plus 4000 equal 4666. This is Laplace criterion. The Laplace criterion. Okay. Now, the maximum expected value according to the above calculation is 4833 for group A. Hence, group A is said to be the best choice. Okay. I would like you to storm your brain and to conduct the solution of the regret criterion. It will be very, very rational issue to understand the theory of decision. I would like to thank you very much for your patience. This is the last lecture of operations research. I will do my best to react to your questions, problems, as I promised before. Do your best. Try to jump over the difficulties, struggle, and as we say, Giddam, go Giddam, and I'm trusting your perch and well. Take your decisions, never give up. Okay. Example 2. Given primal as linear programming problem of minimization. We need to convert this primal problem to the dual one. Okay. The components of the primal are usually objective function, mine W is about minimization. Objective function consists of three variables: y1, y2 and y3. The decision variable of these objective functions are 3: y1, y2, y3. The coefficients of these decisions or decision variables are 2 is the cost of 1 unit of y1, 10 is the cost of 1 unit of y2, and 12 is the cost of 1 unit of y3. Also, given two constraints, y1 5 plus 5 y2 plus 3 y3 greater or more than 5. The second constraint, y1 plus 2 y2 plus 8 y3 more or equal 3. Now, once we have 3 decision variables, then the non-negativity condition represents these 3 decision variables or variables y1, y2, y3, should be more or equal 0. Our duty is to remove the primal problem to the dual one. Again, let's remember the instructions or the step of conversion. First, minimization becomes maximization. W becomes Z. Y becomes X. Right. The variable of the dual should equal the constraints of the primal. The primal gives 2 constraints, then the dual will consist 2 variables. It will be x1 and x2. The parameters or coefficients of the objective function will be the constants of the constraints of the primal. 5 will be the coefficient of x1, 3 will be the coefficient of x2. Then the objective function of the dual will take the following equation: max z equals to 5x1 plus 3x2. Let's step forward. How to design the constraints of the dual. The numbers of the constraint in the dual or of the dual equals to the number of variables in the primal. The primal has 3 variables: y1, y2, y3. Then respectively the dual will contain 3 constraints. the column, the first column of the constraints of the dual is the first row of the primal, and the second column of the dual represents the second row of the constraints of the primal, or the first constraint in the dual is the first column in the primal. The second constraint represents the second column in the primal. The last row of constraint in the dual represent the last column of constraints in the primal. Now, as we mentioned, the constraints of maximization all time is less or equal. Constraint number 1, x1 plus x2 less or equal what? Equal the coefficient of y1, which is 2. The second constraint, 5x1 plus 2x2 less than or equal 10. What is 10? 10 stands behind what? The coefficient of the second variable. 10 is the coefficient of y2. 12, 3x1 plus 8x2 less or equal 12. What 12? 12 is the parameter of what? Of the variable y3. Then 3 constraints equals 3 variables in primal. Two variables in the dual equal 2 constraints in the primal. Okay. Now, the variables in the dual are y1, y2, y3 more or equal 0. The variables in the dual are 2 only, x1, x2 more or equal 0. Please, actually the primal problem in example 2 was the dual in example 1. Please step back to the example 1. You will find that we remove the dual option in example 1 to the primal problem in the example 2. We can play with this game as long as we need. Now, so how to the conversion of minimization to maximization, and the conversion of maximization to minimization. This is very easy and very exciting practices. We will go deep to explain and identify the features of this problem. example 4. An aluminum plant turns out two types of aluminum, X1 and X2. Type X1 takes 6 hours for melting, 3 hours for rolling, and 1 hour for cutting. Type X2 demands 2 hours for melting, 5 hours for rolling, and 4 hours for cutting. The plant has 36 hours for melting time available, 30 hours of rolling time available, and 20 hours of cutting time. The profit margin is $10 for X1 and $8 for X2. Reduce the data to equation and inequalities suitable for finding the profit, maximizing the output mix. Now, this company plans to produce two types of product, X1 and X2. The example mentioned 3 stages of production or 3 processes of production: melting, rolling, and cutting. That means each product should pass these 3 stages. Now, X1 takes 6 hours for melting and 3 hours for rolling and 1 hour for cutting, while X2 demands 2 hours for melting, 5 hours for rolling, and 4 hours for cutting. Now, let's check our available time for this plant or company. For melting process, the company has only 36 hours. For rolling process, the company has only 30 hours. And for cutting process, it has 20 hours. The profit of 1 unit of X1 is $10, while the profit of 1 unit of X2 is $8. Now, once we are talking about profit, once the example 4 is talking about profit, that means the objective function is about profit maximization. That means the objective function is about profit maximization. 2, once there are 3 processes of production or 3 stages of production, respectively, there are 3 constraints or 3 restrictions. For example, the first constraint illustrates or expresses melting. The second stage illustrates or expresses rolling, and the third constraint expresses the process of cutting. So, as we mentioned, let me Repeat again. $10 is the coefficient of x1, indicates the profit of 1 unit of x1. $8 is the coefficient of x2, which indicates the profit of 1 unit of x2. Okay. Now this table will help us to formulate the linear programming problem for this plan. Our goal is to maximize profit of this company using the mentioned data and equation. Reduce the data to equation and equalities suitable for finding the profit, maximizing the output mix. Okay. Now let's convert this table into linear programming problem. Check the next slide. The application of least cost methods. Given the same matrix or of which we gave it to the we use it to apply the north-west corner method. In order to compare the two solutions, the solution of the north corner methods and the solution of the least cost method. That's why now we are going to fix the same matrix. The required is find the total cost using the least cost methods. Given of course 3 sources and 4 market centers and stock of each source and the total demand and the condition satisfied, the total supply equal the total demand equal 1200 units. The main tool in this process, the main starting point is the least cost. So we will start our solution with the cell of intersection point between D2 and source 1. Between D2 and source 1. Now we will go to the next slide to see practically how to apply the least cost methods. Remember that the initial point to solve this problem is the least cost, which is shown in the mentioned matrix equal the least cost in this matrix equal $1, the intersection point between D2 and source 1. Okay, Table 8.1 Sequence of activities for house construction project. Number of activities or activities A, B, C, D, E, F. Column 2 is about starting and finishing event for each activity. So the start event, for example, for activity A 1, and finishing event for A is 2. B is starting at 2 and finishing at 3. 3 respectively, starting at 3 and finishing at 4, etc. So the description of activity. Of course, each activity has certain job. Activity A, to prepare the house plan. B, to construct the house. Activity C, to fix the door, windows. Activity D, wiring the house. Activity A, paint the house. Activity B, polish the doors and windows. Let's check the predecessor, أنشطة السابقة. Activity A has no predecessor. The predecessor of B is A. The activity before C is activity B. The activity also before D is B. The predecessor activity of E is C, and the predecessor activity of F is G. The duration time. Activity A will take 4 days. Prepare the house plan takes 4 days, while construct the house takes 58 days. Fix the door and windows 2 days. Wiring the house 2 days. Paint the house 1 day, and polish the doors, windows is 1 day. The total is 68 days. Shoot. Now the question is how to construct a network for this project. Now let's see. First, this project faces 3 events. Starting event is number 1 and finishing event is number 6. Between these 2 events there are 6 activities: A, B, C, D, E, F. The starting event is number 1. Between number 1 and number 2 event there is an activity for preparing house plan. It costs 4 days. The second activity is for constructing the house. This activity places between event 2 and event 3. It takes 58 days. Okay. The predecessor of activity B is activity A. Now, the activity C is for fixing the doors and windows. It costs 2 days. But activity C will start after the completion of activity B. And also activity D starts after the completion of activity B. So the connection between event 3 and event 4 is activity C. The connection between event 3 and event 5 is activity D. Okay. Activity E exits from the event 4, while the activity F exits from event 5. Paint house one day. This is about activity E. And polish the doors takes 1 day. This is from event 5. The last event is 6. The last event is 6. This is how to draw or how to construct a network for the project of house construction. The project of house construction is easy, just how to follow the predecessor. This is the main, how to follow the predecessor. Okay. Okay. A convenient analytical and visual technique of PERT and CPM prove extremely valuable in assisting the managers in managing the project. Both methods play a distinguished role in the process of network analysis. So let's check the differences between PERT and CPM. Since PERT was developed in connection with an R&D, research and development, therefore it had to cope with uncertainties. But underline under uncertainties, we say that once PERT developed in connection with an R&D, research and development jobs, therefore it had a it has a common relation with the uncertainties. Uncertainties which are associated with such activities. In PERT, the total project is regarded as random variable متغير عفوي, and therefore associated probabilities are calculated so as to characterize it. That this information emphasizes that the PERT techniques or the roots of PERT techniques goes to the R&D job. Once we are talking about R&D jobs work, respectively the suitable condition under which we take a decisions for implementing the project of R&D, obviously under uncertainties, lack of information and data. PERT, it is an event-oriented network because in the analysis of network, emphasis is given to important stage of completion of task rather than to the activity required to be performed to each a particular event or task. That's why PERT is event-oriented activity. Is event-oriented technique. PERT is normally used for projects involving activities of non-repetitive nature, in which time estimates are uncertain. New projects suitable for new projects. It helps in pinpointing critical areas in a project so that necessary adjustment can be made to meet the scheduled completion data of the project. Summarizely, the main characteristics of PERT: first, event-oriented, stochastic or probabilistic, not deterministic because of the lack of information and data. Concerned with time, not known a priori. Sabio. 3 times are possible. Let's jump to critical path methods. المسار الحرج. Since CPM was developed in connection with the construction project, which consists of a routine task whose resources, requirement and duration were known with certainty. So, repetitive. The information and data are available. The decision concerned with the construction is under certainty. That's why we describe CBM method as deterministic method. CBM is suitable for establishing a trade-off for optimum balancing between schedule time and cost of the project. CBM is activity oriented, not event oriented. Activity. We will show the difference between activity and event. CBM is used for project involving activity of a repetitive nature. One time in CBM is possible. These are the main differences between program evaluation and review technique between brackets PERT and critical path method between brackets CBM. We need to understand this clearly. However, lately the modern approaches they don't differ between the role of PERT and the role of CBM in network problem. والله والله